Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. So welcome to my class. So today we are going to do a module that is the DC network theorem, and in that module we are going to do the superposition theorem. So today's topic is all about the superposition theorem, and from today's class we are going to able to understand what is superposition theorem, what is the conditions for applying superposition theorem. Then we can able to understand what is the procedure to solve the superposition theorem, what are the limitations we have with the superposition theorem. So today's topic, as we can say now, that is superposition theorem. So the today's topic is this superposition okay. So first we will cover in this particular module that what is superposition theorem. Next we will see that how to solve the superposition theorem, what are the limitations we have. So first, what are the conditions? So what are the conditions for applying superposition theorem? So first condition, we can say that a circuit which contains linear element, there we can apply the superposition theorem. So the linear circuit. Okay. So number 2 point, the circuit should be here, in this case the circuit should be bilateral. So what does that means, that bilateral? So first we have to know what is linear circuit, then we have to understand what is bilateral circuit. Then after that we are going to solve the other things. So this is your first year class, so you know that in this particular basic electrical syllabus we are going to deal with only with the DC source. So we know that within RLC, that is the resistance, inductor and capacitor, only with the DC source the resistor can go. So now we can say that in the DC network theorem we have only the DC source, and the second thing we have the resistors. Now consider our resistor. Okay. Now say we are connecting a source over here, not AC, we should use a DC source. Okay. So if we connect a DC source over, what will happen? The current will flow from this side to this side. Okay. Now if we do that, if we disconnect this one from here and if we connect over here, so what will do? The current will flow like this way. So that means if we connect positive terminal over here and negative terminal over here there, then what will happen? The current will flow from this side to that side. Or if we connect a positive terminal over here, negative terminal over here, so the current will flow from this side to this side. So this property is known as the bilateral. So this one. Okay. So next point is the linear circuit. What is a linear circuit? So linear circuit means through first, to understand this what is linear circuit, first we have to understand what is linear element. So as per definition, it is told that element through which the VI characteristics which has a linear VI characteristic, that is known as the linear circuit. That means, say again consider our resistor. Okay. Now say a 10 volt supply is given. So say due to that 0.1 ampere current is flowing through the circuit. Okay. Now if we increase the voltage value from 10 volt to 20 volt, what should happen? The current value, say now that is 0.2 ampere. So that means when the increasing value of voltage, the current is also increasing. At the same time, with the decreasing value of voltage, if the current is decreasing, then we can say that between voltage and current we have a linear characteristics. That means if we draw a curve between V and I, we will get a straight line, that is Y is equal to mx plus c. Okay. So the element which actually follow this Y is equal to mx plus c characteristics equation, so that is known as the linear element, and a circuit which contains a linear element is a linear circuit. Okay. So these are the conditions for applying the superposition theorem. That means first two conditions for applying superposition theorem is that the circuit should be linear and the circuit should be bilateral. And after that we can say that the most important, which is the unique characteristics of superposition theorem, that when we can say that for that particular circuit we can apply the superposition theorem. That the point is the circuit must contain at least two sources. That means a circuit which contains at least two sources, maybe voltage, maybe current, there only we can apply this superposition theorem. That means if we have 1000 source in a circuit, yes, we can apply the superposition theorem. But if a circuit has a one source only, then we cannot apply the superposition theorem, because the superposition theorem tells us that a circuit which contains two sources or more than two sources, there only we can apply this superposition theorem. So these are the conditions. Then if those conditions are satisfied, then only we can use the superposition theorem. So that means what? Linear circuit, that means the VI characteristics should be linear. Bilateral means the both direction current can flow, and the next one is that the circuit must contain at least two sources. Okay, so these are the three conditions we have. Now we are going to deal how to solve this one. Okay, so now we are going to deal with how to solve this circuit. So for that we are considering a source which must have two sources. So we are we are considering a circuit. Say we are considering this circuit. Say this is our circuit. Okay, so now for the simplicity we are considering this is V1, this is V2, this is R1, this is R2, and this is R3. And we can say that the question statement is like that: find out the current passing through this R3 resistor using the superposition theorem. Now first we have to identify that, can we apply the superposition theorem over here? Yes, we can apply. Because why we can apply? Because it's satisfying all the conditions that we need for applying the superposition theorem. What are the conditions? Two source at least. Yes, we have two source over here. The circuit should be linear, the circuit should be bilateral. Yes, we have only resistors which has a property of linearity, and the resistance is a bilateral element. So yes, we can apply the theorem. Now the point is how we can solve the superposition theorem. So as per this theorem is concerned, that is in superposition theorem, whenever in a linear bilateral circuit which contains at least two sources, so there we can apply the superposition. That we have understood till now. Now how to solve? What is the procedure to solve? So the point is that when a circuit contains two or more than two sources, so at that time, as per superposition theorem, we can consider a single source at a time, and for that source find out what are the branch currents and what are the branch voltage. Like this way, consider a single source at a time, and then find out what is the individual current for each source, and at the end we have to add or subtract the current as per their current direction. Okay, if the current direction is the same, they will be additive. If the individual current direction is opposite to each other, then they will be subtractive. So like this way we can solve this theorem. So now this is our circuit, and our aim is to find out what is the current. Say this is the I3 current. We have to find out that I3 current, what is the I3 current through this R3. So now we will go like as the theorem is stated that. So first we will consider step 1. So in step 1, what we are going to do, we will going to consider a single source, and due to that we are going to find out what is the total current passing through the each branch. Okay, so consider any one source. Say we are considering this V1 and we are removing this V2. It should be mentioned over here that when we are removing source, that time we have to consider that when we are removing the source, we have to left in the circuit its internal resistance. Okay, so for this particular problem we are considering we have two ideal voltage source. So if we have two ideal voltage source, then what we can say? We can say that ideal voltage source has zero internal resistance. So when we have to remove the voltage source from the circuit, so at that time we have to make that terminal short, because a short terminal is always offers a zero resistance. Okay, so that's why when we are removing ideal voltage source from the circuit, so that time we are shorted that terminal. Now we are going to see how to solve. This is V1 we have considered, this is R1, this is R2, this is R3, correct? So now we are going to find out, see, now say we can say that, so the current is this, okay, so that current is flowing like this at this node, this current is dividing as per the resistance value. Okay, so we can say that the current is producing from here and it is dividing at this node. Now our aim, what is our aim? Our aim is to find out what is the current passing through this R1, what is the current passing through this R3, and what is the current passing through this R2. Okay, so to find out that, first what we have to find out, we have to find out what is the main source current, because after finding out that main source current, we can find out, applying the current division rule, what are the branch currents, correct? So first we have to find out the source current. Now how we can find out the source current? We can find out the source current by using the equivalent resistance method. So first of all we have to find out the equivalent resistance of the circuit, then the voltage source value by the equivalent resistance will give us the main source current, then apply the current division rule to find out the branch current. So we will find out the equivalent resistance. So what is the equivalent resistance? So we can say that, so the current is passing through first this one through R1, then it is flowing through this R2 and R3. So we can say that at its node these two are dividing, so these two are in parallel, with that this one in series. So we can say that this R2 R3 in parallel with that R1 in series. So this will give us the total equivalent resistance in ohm, correct? So now we can find, say give a name for your simplicity. So this is I1 bar, so give a name, this is I2 bar, this is I3 bar. Okay, so here we can find out now that this is I1 bar. So I1 bar is this V1 by R equivalent. This will give us by the ampere. So now this I1 bar current is dividing into this two section. So now we can apply the current division rule to find out the result. Okay, so what is the current division rule? So we know that I2 bar is equal to, we can write down the total incoming current, that is I1 bar, into what we can say? We can say that the opposite branch resistance, we are going to find out the I2 bar flowing through this R2. So parallel to R2 resistance is this R3. So you have to write down over here the R3 by the summation of those two parallel resistances. So that is R2 plus R3. This is in ampere, correct? So like this same way we can find out the I3 bar. So what is I3 bar? So I3 bar is equal to, this is I1 bar into this. Now we are finding out this I3. So opposite of parallel opposite is this R2. So over here we have to write down the R2 by R2 plus R3 in ampere. So now we know all the currents passing through each branch. So this is the procedure for the first step. Now the same procedure we have to maintain for the second source. Now we are going to, in the step 2, we are going to consider this source and we are going to remove that source, and in that case also this V1 is as it is an ideal source. So after removing that terminal we have to left over there zero resistance. That means zero resistance means we have to make that terminal short. Okay, so let us do that. Before that we have to remove this one from here. We have to remove this. Okay, so we are going to remove but the thing is that in the second step, the same thing we have to follow. That means we have to find out the equivalent resistance, then we have to find out the main current, then we have to find out the branch currents, but in the opposite direction. So let us consider the second source. So here now, so this is our main circuit. So this is our main circuit. I should not delete this one. This is V1, this is V2, this is R1, this is R2, this is R3, and our aim is to find out this I3 through this one. So now we are going to consider this source and we are going to remove this one. So step 2, consider this source, remove that one. So we are considering this is V2, this is R2, this is R3, this is R1. Okay, so now we have to find out the current producing from here. That current is coming to this current is coming to this node, then it is dividing. So again give some name. So for the simplicity, this is giving I2 double bar, this is I3 double bar, this is I1 double bar. Okay, so first of all, so the main current is here is the I2 double bar because this is the source current. So first of all we have to find out the source current. So in the previous step what we have done, so finding out the source current, first we have what we have done, we have find it out the equivalent resistance, then we have find it out the main current, then applying the current division rule we have find it out the branch current. So first we have to find out the equivalent resistance. So first we have to find out this one. So what is this one? R equivalent. How to find out this R equivalent? So we have to find out what is the series parallel combination of this resistance over here. So what is the series parallel combinations of resistance over here? Let us see, we can say that, so the current is producing like this, it is flowing through this, and at this node it is dividing in between two. So if it is dividing in between two, so we can say that these two are in parallel, with that this R2 in series. Again, so as this current is dividing between this R1 and R3, so that means they are in parallel, with that the R2 in series. So we can say that R1 R3 in parallel, R1 plus R3, with that R2 in series. Okay, so this is the total equivalent resistance we have, this is in ohm. Okay, so now find out the main current, that is I2 double bar, that is given by the supply voltage V2 by the equivalent resistance, that will give us the R equivalent, that is in current ampere. Okay, so that is the main current. Now we know that what is the current flowing through this one. Now applying the current division rule. So what is the current division rule? Current division, applying the current division rule, you have to find out this I1 double bar and this I3 double bar. So what is the formula? Again, the main current into opposite branch resistance by the summation of two parallel resistances. So here in this particular circuit, when we are considering this V2, so at that time the main current will be the I2 double bar. So here we will consider this I2 double bar into opposite branch resistance of this. We want to find out the current passing through this I1, correct? Now when we want to find out the current passing through this I1, so that means the opposite parallel of that resistance is R3. Okay, so these two are in parallel, so we want to find out the current passing through this one. So parallel to this one is this, so this component would be over here by the summation of this R1 plus R3, this is in ampere. Like this way, I3 is equal to, that is I2 double bar, this is I2 double bar by this is R1 by R1 plus R3 in ampere. So let me consider that we are going to find out the current passing through this one. So if we want to find out the current passing through this one, so parallel opposite to this resistance is this R1, so that's why R1 over there, and the summation of this parallel resistance. So now we know the current passing through this R1, R2 and R3, all resistance currents we know. So the one main point is that step by step we have solved each source, and due to that we have find it out, so what are the current passing through. So now at the end, now the step 3 we have to do. In the step 3 what we have to do, according to the direction of the current, we have to add or subtract the current values. So now, so for your simplicity, for better understanding of you, say this one our first circuit, this is R3, this is R2. So there we have considered that is I1 bar, this is I3 bar, and this is I2 bar. Now just cross check what are the directions and of this two current. So we can say that this I3 current, sorry, first we should start with I1. So I1 is the total current due to the presence of both source. So can we say that we have a I1 over here, there is I2 over here, and the current value is in the I3. So this I1, I2 and I3 is a combined effect of the both sources, that is the positive due to the both sources connected in the two arms of this circuit. So now the point is we have to add or subtract the current as per the direction. So let us see what is the direction. So first, this I1 is a combination of this I1 bar. So for this particular circuit we have I1 bar, and for this particular circuit we have I1 double bar. So we can say that I1 is a summation, vector summation is I1 bar and I1 double bar. Now the point is both will be additive or both will be subtractive. It depends upon the direction. So let us check the direction. So what is the direction? See, when we are considering the step 1 diagram, so there the direction of current was from this side to that side, and we are considering the step 2, so current direction is this side to this side. Okay, so the directions are opposite. So again I am telling you I1 direction for the step 1 is this, and the I1 double bar direction in step 2 is this. So we can say that both will be subtracted. Now the question appears, from I1 bar to I1 double bar it will be subtractive, or I1 double bar to I1 bar it will be subtractive. It depends actually the value of that one. So when we were going to solve problems, you should have some values. So from the bigger one to smaller one you have to subtract. So like that way, say we are considering that I1 bar is a higher value and I1 double bar is a smaller value, so we can say that there is a minus because the both directions are opposite. So like this way, so we are considering I2. Obviously I2 is a summation of this I2 bar and I2 double bar. The other point is it will be additive or subtractive. Okay, so now again we have to check the direction. So again step 1 circuit direction and step 2 circuit direction. Again in step 1 we have I2 bar, and step 2 we have the I2 double bar. So it's coming to the step 1. So this is the step 1. So in step 1 I2 bar direction is from this side to that side, correct? And step 2, okay, so this is the direction. So we can say that the direction of I2 bar double bar is this. So I2 bar direction is this and I2 double bar direction is this. That means both are opposite. So if both are opposite, so there will be minus. Okay, so now the last, that is I3. So now I3 is a summation of this I3 bar and I3 double bar. Now let us check what is the direction of this I3 and I3 bar and I3 double bar. So for step 1, the direction of I3 bar is from here to here, downward direction. And from step 2, what is the I3 double bar direction? From again the same direction, the downward direction. So that will be additive. So this is the procedure by which we can solve this superposition theorem. So now the limitation. So the limitation of this superposition theorem is that superposition theorem cannot apply for the power calculation, because power is a complex not a first order function. So but we, as per the theorem is concerned of superposition theorem, it is a linear theorem. So we cannot find out the non-linear or not the first order function, it is a second order function. So that's why we cannot apply the superposition theorem for the power calculation. So where we can apply the superposition theorem? So we can apply the superposition theorem where we want to find out the branch currents or branch voltage. And obviously when there are different kinds of source are present, so there we can apply the superposition theorem. So like this way we can solve different problems when there are different sources, maybe voltage, maybe current. So here I have solved a circuit which has only 2 voltage source. A circuit may contains 2 voltage source and a current source maybe, but for your understanding, I have here explained only with the 2 source. Okay, so this is all for today. Thank you.